Our task 2, we're going to be dealing with exponents and sets. You have your equations, you have your trigonometry. And then on trigonometry, we're going to use the diagram. We have identities, and then we also have the reduction formula. The structure of the test, it looks something like this. If we can check here on question number 1. Question 1, it's similar to what you are going to be writing in grade 12. It's exactly the same thing. Question 1 of the final paper of grade 12, it's similar to this one. So you have about 28 marks. And then on question 2, they say we should simplify without the use of a calculator. So we're going to be dealing with equations and sets, exponents and sets. And then if you go to your question number 3, you're proving the following identity. So they gave us one question, that's 5 marks. And then we go to question 4. Question 4, you have your trigonometry, whereby here you are going to use an aid of a diagram. And then here you're going to be simplifying. So we're currently busy with this. So we know how to use a reduction formula. And then they say without the use of a calculator. Now, in each and every question, what is important are the instructions. So this is the test that will come and write after we are done with this one. So we're going to start with our instructions. In each and every test, it's very important that you go through the instructions. Instruction number 1, it says this question paper has 4 questions, meaning there is question 1, question 2, question 3, and question 4. You should check that. They say that you should clearly show all your calculations. Number 2. Number 3, they say an approved calculator, non-programmable, non-graphical may be used. So you can use a calculator. And then they say number the answers correctly according to the numbering system used in this question paper. If necessary, they say you should round off your answer to 2 decimal places unless they state otherwise. Diagrams are not necessarily drawn to scale. It is in your own interest to present your work neatly and legible. So let's go through our tests. On 1.1.1, they say we should solve for x. Okay? So if we're going to solve for x here, if you check in between here, there's no plus. So if there's no plus, it means which we can apply what they call the product rule. Remember, guys, they said we should number according to the numbering system used in this question paper. So if you're going to write 1.1, you say 1.1.1, and then you start to write it. They say you have x plus 3, and then you have 2x minus 3, which is going to be 0. What we'll then say is that this is going to be 0. So you have x plus 3, which is 0, or 2x minus 3, which is going to be 0. And then from here, you take the 3 to the other side. If you take 3 to the other side, what are you going to have? So we have x is going to be equal to minus 3, or we have 2x, which is going to be 3. I want x. How do I get x? So I will divide both sides. So if I divide by 2 and then divide by 2, it says x is going to be equal to 3 all over 2. So how do they mark this question here? So in this one, they are going to give you 1 mark for 1 answer and 1 answer. Again, it's already factorized. Can you see that? So because it's already factorized, they are going to give us 1 mark for each answer. Now, even if you multiply through here, and then you use the quadratic formula. But if there's no plus in between, just keep that in mind. You can apply the product rule. Because most of the time, what happens is that you will then multiply and then you will get it wrong. Where else you could have went straight to the answer. In fact, the first question, most of the time, if you see them brackets, just know which they want you to go straight to the answer. Let's go to 1.1.2. On 1.1.2, they say, leave your answer in a simplest set form. We are following the instruction. So we should leave our answer in a simple set form. They didn't say we should round off into 2 decimal places. So we're going to leave our answer in the simplest set form. Now, if they say that here, this is also a quadratic, we first have to put it in a standard form. So let's go to 1.1.2. It says we're going to have 6x squared plus 8x minus 16, which is going to be equal to 0. Now, if you see an instruction whereby they say, leave your answer to 2 decimal places, leave your answer in a simple set form, you're going to use the quadratic formula, or you're going to use completing the squares. The simplest one is to use quadratic formula. So we'll say our A. What is our A here? So we have A 6. What is our B? We have 8. What is our C? Minus 16. Unfortunately for us, we're in grade 11. The quadratic formula is not provided. So we'll have to know it. So it says we have X is equal to minus B. And then we have B squared minus 4AC. All over 2A. Okay, let's substitute them. What are we going to get? X is equal to minus, open bracket. And then we have 8 plus and then minus 8 all squared minus 4 multiplied by 6 multiplied by minus 16. This is going to be all over 2 multiplied by 6. Okay. So yeah, as we said, in this question here, they are going to give us a mark for calculating what we call the discriminant, whatever is inside the inside your root here. They are going to give you a mark for calculating whatever is inside the root. So we'll start by that using our calculator. So we are going to have 8 all squared. You see what I'm doing now? I'm just calculating whatever is inside without the square root. The square root is not there. I'm just calculating whatever is inside the square root there. It's important because you get a mark for the discriminant. So it's 8 all squared minus 4 multiplied by 6 multiplied by negative 16. And then we get 448. So we say X is going to be equivalent to, if we say negative multiplied by positive, it gives us minus 8 plus and a minus square root of 448. And then if you say 2 multiplied by 6, it gives us what? 12. Yeah, you get a mark for this. Remember, you're going to get 1 mark for putting it in a standard form, 1 mark for putting it in a standard form, 1 mark for getting the discriminant here. Mistake number 1, when you calculate the discriminant, you don't put the square root. Square root is not there. So you simply calculate whatever is inside the square root. They are going to give you a mark for that. And then next. Then now you can use your calculator to simplify this further. You say you have minus, you open your bracket, 8, close bracket. Our calculator doesn't have a plus and a minus, so we start with plus. And then we have 8, close bracket, all squared, minus 4. Guys, remember it's plus, not minus. So we have 6, close bracket, minus 16, all over 2 multiplied by 6, close bracket. And then it says which our answer, X is going to be equal to minus 2 plus root 2 all over 7 all over 3. Yeah, and then remember they said, so here you can say plus and the minus. If you go and check the minus is all going to give you exactly the same thing. So you come here and say, instead of plus, let's change this and make it to be minus. So if you say minus, it gives us the same thing except there's a plus here. So you can say minus 2 plus and a minus square root of. Now, because the examiner said we should leave our answer in a simple set form, then we're going to stop here. We're not going to give them another answer. So we'll say X is going to be minus 2 plus square root of 7 all over 3, or X is going to be equal to minus 2 minus square root of 7 all over 3, and then you are done. Again, remember, guys, we're looking at the instruction. As I was saying here, you need to look at the instruction. What does the instruction say here? The instruction says leave your answer in a simple set form. Set form is not rounding off to 2 decimal places. Should you leave it you leave it at the root form. That's a set form. And then if you can check this question, it has 4 marks. So where do you get your 4 marks? As we were saying, You're going to get 1 mark for putting it in a standard form. That's the first mark. Second mark for correctly substituting. And then you are going to get your third mark here. On the discriminant, we give you 1 mark, and then the final mark is going to be your answer. Both answers, you are going to get 1 mark. Are we good then? I should go down. Okay. Yeah. Wait. Oh, yeah, you're right. Sorry about that. So the answer, I should copy it exactly the way it is. So it's root 2 square root 7. Okay? So even here it should be. In fact, I should have stopped here so that I don't make a mistake. Can you see that? Okay? Yeah. So if you do unnecessary stuff, because there's no mark for this, because I said it's plus and a minus root 2 all over 7. And then I started making mistakes then. So here you are going to have 2 root 7 all over 3. Okay. For this one, it's minus. The other one, it's a plus. Let's go to the next question. Can I erase this part? We are done with the first two. Okay? Yes. So we have the next one, they say 1.1.3. We have a variable in the denominator. How do we remove a variable in the denominator, guys? We are going to multiply by the variable. So if it's an equation, if it's an expression, we are going to try to find the LCD. Now, if it's an equation, we are allowed to multiply by the variable throughout. So numbering correctly, we say we have 1.1.3. It says we have 2x minus 3 all over x plus 1 is equal to 0. So you're saying the first thing that I should do, Cassius, the first thing that I should do here, they say I should multiply by x. Everything, I'm going to multiply everything by x. So it means I will say x multiplied by 2x. That's the first part. Eh? In fact, this is how I prefer we should do it, guys. Let's just be careful here. Let's first write the equation exactly the way it is. So you write x, 2x, and then you put the multiplication this side. And then after that, you have minus 3 all over x again. And then you say this one here is going to be multiplied by x. Then you have plus 1. Then you say this one is going to be multiplied by x. And then this whole thing here, they're saying it should be equal to what? To 0. Okay, let's multiply throughout. This one multiplied by this one, what do we get? So we have 2x squared. And if you say this one multiplied by this one, this x and this x, they will divide each other out, right? And then I'm left with what? Minus 3. And then if you say this one multiplied by this one, it's going to give us plus x, which is going to be 0. So here we are going to have 2x squared. If we put it in a standard form, we should start with squared. What follows is this one. We are not transposing it. So it's still going to be plus x minus 3 is equal to 0. We factorize it. Now, if we are going to factorize here, we can use a quadratic formula. We can open brackets. Okay? Let's open brackets. So we're going to have 2 here. We're going to have x. Should we use brackets or quadratic? Brackets. Okay, let's use bracket. So we have 2x, we have x. Okay? And then from here onwards, we want to have our middle term as what? As x. We know the process. You can use grouping. Right? So in this case, I'm going to put 3 here, and then I'm going to put 1 here. Then here I will have -1, here I will have plus 3. Now, if you check the following, if I say this one multiplied by this one is going to give me 2x squared. Okay? And then if I say this one multiplied by this one, it gives me minus 2x. If I say this one multiplied by this one, it gives me 3x. Okay? Now, if I add this 2 here, it's going to give me what? It's going to give me x. And then if I say this one multiplied by this one, it gives me what? Minus 3. So my factors are correct. They are on point. And then from here, we're going to use the product rule. On our product rule, we're going to say that we have 2x plus 3 is equal to 0, or x minus 1 is going to be equal to 0, which is going to give us x is going to be equal to minus 3 all over 2. You understand how we got minus 3 over 2? Yes. So we took 3 to this side again and divided. So it says x is going to be equal to 1. And then guys, if there's a denominator here, it's fortunately for us, they already told us the restriction here. They said x should not be 0. If they didn't give us the restriction and then we find it here, we're supposed to tell them it cannot be that. It cannot be whatever is going to make the denominator to be 0. Now, how do we mark this one? If you check the marks here, it's 4 marks, right? So we're going to give you a mark by multiplying. Multiplying with x, we give you a mark. Putting it in a standard form, we're going to give you a mark. Factorizing, we're going to give you a mark. For both answers, we're going to give you a mark. So you're busy collecting your marks here. Let's go to the next one. 1.1.4. So 1.1.4, we have an inequality. Look at the following, we have an inequality. So there's an inequality here. So if we have an inequality, we're going to say that we have 7x. And then it says which we have 2x minus 1. And then they say this should be less or equals to 0. So we're not dealing with an equation, but an inequality. So till now we adopted the fact that if we're going to do inequalities, we're going to use the graphical method. So yeah, this thing is already factorized again, guys. We should check those things that are already factorized. There's no plus in between here. So it means that I can say critical values. For me to get my critical values, I will say 7x should be equal to 0. Or I will say that 2x minus 1 should be 0. Because I'm getting my critical values here. And then it says x is going to be 0 or x is going to be equal to 1 all over 2. Still good. Then we're going to our graph now. On our graph, which one is smaller between the two of them? Half or 0? Half. Half or 0. 0 is small. So we put 0 here, and then we're going to put half here. So we put 0 first, and then we put half after that. Now, we are going to check the value of A. How do you check the value of A? You simply multiply these two. If you multiply these two here, it should give you the value of A, so that you know whether A is positive or what, or negative. So if we say this one multiplied by this one, I think we get 14x squared. Now, A is positive or negative? Positive. So our graph is going to smile or sad? So we are going to have the graph that looks like this. So our graph is smiling. Okay, after our graph has smiled, then we're going to go to our solution again. Now we said the smaller one is going to take the original sign again. So the bigger one. The bigger one. So yeah, our solution is because they're saying x should be less than. If they're saying x should be less than, we are saying the bigger one is going to take the original again. In fact, here, our solution is going to lie here because they're saying below. When they say less than, they mean below the x-axis. So if you find your solution here, guys, you can come and write it this way and say, we're going to put the smaller one here. And then we write the inequality. If it has an equals to, we write an equals to. And then you put x in between. Here you put the smaller one, and then here you're going to put the bigger one. Now, let's go back to the method that we're using in class. Again, we said the bigger one takes the original sign again. So it means I was supposed to say x is going to be less or equals to 1 all over 2 again. And then the smaller one is going to take the opposite sign, which means x is going to be greater or equals to what? To 0. Look at this here. You have x, which is less than. X is less than 1 all over 2. This is x is less than 1 all over 2. And then this is x being greater than 0. So you can write a solution this way. Are we good then? How many marks for this thing? Let's go and check. We have 3 marks. Now, because it's already factorized, they are giving us 3 marks. So 1 mark is for the critical value. 1 mark is for the method. There's a mark for the method. And then the last mark is going to be for the solution. We are going to 1.1.5. On 1.5 or 1.1.5, we are dealing with a set, okay? A set equation, and then it has 5 marks. So our set equation here, it has 5 marks. All right, 1.1.5. Numbering according to the numbering system used in this question paper. So if we're going to number according to the numbering system, we have 1.1.5. It says we have root x minus 1 plus 3. 3 is not inside the root again. And then it says which we are going to have x minus 4. Now this one, it was also found on the diagnostic report of last year. Guys, before we square both sides, I think we're supposed to square both sides to remove the root. First, we need to group the set one side, and then things that are not inside the set one side. So the first thing that we're supposed to do here is to take this 3 to this other side here. So if we take this 3 to this other side, we're going to have root x minus 1, okay? Which is going to be equal to x minus 4. 3 is positive, okay? When it goes to that other side, it's going to become what? So you have minus 3 here. What is minus 3 minus 4?
-7.
So we're going to get minus 7 then. Minus 7. Then, guys, that's when you can start to put a square root both sides. You don't start by putting the square root both sides. First, the root needs to be one side, the non-root needs to be one side. And then from here, then you can square both sides. They will give you a mark for squaring both sides. So for doing this, but you need to square sets and non-sets. If when you start squaring here, this is the mistake that learners were making last year. You do something like this square. This is square. This is wrong, by the way. This is wrong. First, you need to make sure which the sets are one side and then the 9 sets are what? Are one side. So I think we spoke about that one at length. Okay, let's move on. Okay, if we square both sides, then we're going to say that this one and this one, they are going to divide each other out. Okay? If you multiply a root with a root, it's going to give you what? Whatever is inside the root. So you have x minus 1, which is going to be equaling to. Now you expand this bracket. This bracket here is going to give you x minus 7, x minus 7. If you say this one and this one, we start to form. X multiplied by x gives us what? X squared. This one multiplied by this one? Minus 7x. Minus 7x. Plus 49.
Yes.
So we have 49. And then we have x minus 1.
Yes.
Now we have 2 things this side. So it makes sense for us to take everything to the other side. Okay? So we're going to take this x to this other side, and then we're going to take minus 1 to this other side. Which means we're going to have x squared. These two are like terms. Okay?
Yes.
And then we still have this 1 here. If we take it to that other side, 1x is going to become negative.
Yes.
So we're going to have what? Minus 15x. And then we take this one, which was negative. If it goes that side, it becomes what? Positive. Then we're going to have plus 50, which is going to be equal to what? To 0. So you could have put your equal sign. In fact, let's put the right thing here so that people are not confused here. So we took everything to that other side. So it means our equal sign is somewhere here. So it doesn't matter whether the equal sign is on the left-hand side or on the what? On the right-hand side. It's an equation. This is a quadratic equation. Then we are going to factorize. If we are going to factorize, as we said, whether the 0 is this side or whether it's that side, it doesn't matter. So we're looking for factors of 50 that are going to give us minus 15. What are those factors? 5 and 10. So we have x is equal to minus 5, and then we have x is equal to minus 10. Yeah, negative and negative is going to give us what? Positive. And then when we add these two, they are going to give us what? Minus 15. And then it says x is going to be equal to 5 or x is going to be equal to what? To 10. Now, mistake number 2, Hotzo. They spoke about learners not checking their answers. As soon as you are done here, you need to go and check your answer. Now, how do you check your answer? On your calculator, you are going to take the original equation exactly the way it is, and then you put x here. You put the value of x. You are going to start by putting 5. You put 5, and then you also come and put 5 here. You are going to check if the left-hand side and the right-hand side are giving you exactly the same thing. Let me put it with the red color so that you'll see what I'm doing here, guys. Here's what we are saying. We are saying you are going to have roots. Instead of x, you are going to put 5 minus 1. Plus 3, which is going to be equal to, instead of x, you're going to put 5 minus 4. And then you check what you get as an answer here. What you get as your answer here. Okay, you write the answer this side. Okay, you get 5 here. And then you come and check the answer this side. What is the answer here? You get what? 1. Is 5 equal to 1? No. So we are going to say this one here is not applicable. So we'll start by saying, okay, it means this one is not applicable. We're not done, guys. We're also going to check the other one. It's possible for them, both of them not to be applicable. It's possible for both of them to be applicable. So let's go and check the second one now. You come and erase here. Where there was a 5 now, you no longer going to have 5, but you have what? You have 10. You come and put 10. You put 10. You put 10. It says, what you get as your answer? You get 6. And then here, what are you going to get? 6. You get 6. Huh? Which means, therefore, our answer is not 6, guys. You should be careful here. We are checking, we get 6 is equal to 6. Okay? Meaning, therefore, x is going to be equal to what? To 10. Now, let's check 5 marks. How do you get your 5 marks? You're going to get 1 mark for squaring both sides. You're going to get 1 mark for putting it in a standard form. You're going to get 1 mark for factorizing. You're going to get 1 mark for both answers. And then choosing which one is applicable and then which one is applicable. They're going to give you 1 mark. If you stopped here when you didn't tell them which one is applicable, which one is not applicable, you get how many marks? 4. So we shouldn't lose that mark unnecessarily. What do we check? I've been doing 1.1, 1.2, 1.3, 1.4. Have I checked? Did you see me checking them? When do I check? 1.5. Why did I check 1.5? Because they are the same. Yeah, because of this root here, we are going to check our what? Our arms. Yeah, my hand is tired. Anyway, let's move on to simultaneous equation. Simultaneous equation is 6 marks. There was a learner who said they have a problem with simultaneous. I won't call you by name. It's our secret. It's going to be our secret. No, there's nothing wrong, guys. Simultaneous equation, in fact, it's a challenge. Man. In fact, we should practice more often. So let's go to our simultaneous equation. I should take a bigger eraser. This one is small. Yeah. All right. It says 1.2. We have 3x minus y, which is going to be equal to minus 2. We have y is equal to, oh. Okay, so we have it here, guys. So we are going to say between the two equations, we are going to check which one seems to be simple between the two of them. Which one do you see seems to be simple? Equation number 1, equation number 2. So it's equation number one, it's a linear. So if equation number one is a linear, we're going to try to make it to be a little bit simple. Equation number one, we're going to try to make it to be a little bit simple. Okay, in this case, what are we supposed to do? Are we going to make X or Y the subject here? We're going to make Y. How do you make Y? So you're going to first start by saying, should we take Y to this side or take 3 to this side? Which one should we do? You think which we should take 3 to this side. Okay? So if we take this 3 and then it comes this side is positive, it's going to become what? So you're going to have minus Y. Don't forget, this is minus Y, this whole thing here. And then you have, this is going to be equal to minus 2. You take this to this other side, it says you are going to have what? Minus 3x. That's one way in which it could have been done, actually. Okay, we are not done. We are looking for Y as the subject. Okay? So what are we supposed to do here? So we're going to divide this by -1, divide this by -1, and then divide this by -1. And then it says Y is going to be equal to this. Huh? Oh. So we have Y is going to be equal to 2 plus 3x. And I will call this one equation number 3. Okay, this one is going to be our equation number 1. This one is going to be our equation number 1, number 2. So what is the next thing after that? The next thing we're going to sub equation number 3 into equation number 1, number 2. So sub equation number 3 into equation number 1, number 2. So we have everywhere we see Y, we go to an equation and check if there's a Y. So there's a Y here. Can you see that? Is there any other place where there's a Y? Yeah, if you look at this, this is the only place where there's a Y. So we're going to substitute where we see our Y. So we're going to have, instead of Y, we're going to put 2 plus 3x. So this is where we see our Y, we put that again. And then we continue with our equation. It says we have minus a, which is going to be minus x squared plus 2x. And then from here onwards, it's a matter of putting it in a standard form. Now let's take this, because here we have 3 people, here we have 2. Let's take the 2 to the other side again. So this one and this one, they are like terms. This one, if we take it to this side, it's negative again. When it comes this side, it's going to become what? So you have x squared. Positive again. If it comes to this side, it's going to become what? So you have 3x minus 2x. What is 3x minus 2x? X. So it's plus x. And then you said these two, they were also like terms, which means they're going to give us what? So you have 2 minus 8. Okay? What is 2 minus 8? Minus 6, which is going to give us what? 0. Then open our brackets. Guys, if you're still not comfortable with factorizing, please, I beg you, use a quadratic formula. So you have x, and then you also have x. Okay? And then you are looking for factors of 6 where you subtract, and then they need to give you what? These. So you have plus 3 minus 2. Says x is going to be equal to minus 3, or x is going to be equal to what? 2. We're not done again. We're going to take these values that we got, and then we're going to sub them in equation number 3. The values of x that you got, the values of x that you got, you are going to come and substitute them here. So you're going to have y is equal to 2 plus 3 multiplied by minus 3. And then you get an answer. What do you get? You get 7, minus 7. Minus 7, or you say y is going to be equal to 2 plus 3 multiplied by 2. It gives us what? An 8. Now you can come and put your, you can put them in a coordinate form and say this one goes with this one. This one goes with this one. You start with x. So you say, what is our x? Our x is minus 3. What is our y? Minus 7. So when x is 3, y is minus 7. When x is 2, our y is going to be 8. So we go to our last question. This one, guys, nature of the roots. Nature of the roots. They say, oh, let's mark this one. This one is 6 marks. Where do we get our 6 marks? First mark is for getting equation number 3. Second mark is for substituting. Third mark is for putting it in a standard form. And then the fourth mark is going to be factorizing, getting both values of x and getting both y values, and then you get your 6 marks. Let's go to the last one. Last one on question number 1, which is 1.1.3. They are saying, determine the values of p for which this thing here is going to have non-real roots. Let's first talk about what do they mean when they say we have non-real roots. So they are saying which is, the discriminant is going to be less than 3. So that's the first thing that they are talking about. If they say for which values of p we are going to have non-real root, they are saying the discriminant should be what? Should be less than 3. But now, how do you approach this question? The first thing that we're going to do is to get the discriminant. How do you get the discriminant? You first have to put it in a standard form. On 1.3. So this is not 1.1.3, it's 1.3. So they are saying for which values, we are saying the first thing that we are going to do is to put this thing in a standard form. So on a standard form, we're going to group everything one side and then make sure which one side is equal to 0. So you're going to have your 2px squared. And then if you take these to this other side, it's going to become what? So you're going to have minus 3x. If you take the 8, which is negative, and then you take it to the other side, it says plus 8. This is going to be 0. So we give you a mark for putting it in a standard form. And then the next thing that you're going to do here is to say, what is A? A is the numerical value which is before the x squared. And then this here is going to be your B. And then this here is going to be your C. So what is our A here? It's 2p. What is our B? Minus 3. What is our C? It's 8. And then we go to our discriminant. The discriminant, it says we have b squared minus 4ac. And then we have minus 3 all squared minus. And then we have 2p and 8. And then if you say minus 3 all squared, guys, this is how we type a square in your calculator. You don't type it this way. You don't say minus 3 all squared. No, because this is going to give you minus 9. It's wrong again. Whenever you type it this way, open bracket, minus 3 all squared. And then it says which you are going to have a 9 again. And then if you say this one multiplied by this one multiplied by this one, it says 4 minus 4 multiplied by 2, it's minus 8. Minus 8 multiplied by minus 8, it gives us minus 64p. Again, it's minus 4 multiplied by 2. Minus 4 multiplied by 2, it gives us minus 8. Minus 8 multiplied by 8 is going to give us what? Minus 64. Then we are saying, since they're talking about non-real roots, it means this whole thing here should be less than 0. So we'll say 9 minus 64p should be less than 0. And then from here onwards, you want to solve for p again. Now your linear inequality and your linear equation, we approach them exactly the same way. A linear and an equation, they are exactly identical. Quadratic, we solve them in a different way. So I'm going to take your 9 to the side. It says you have minus 64p, which is going to be less than minus 9. Still good, right? Then we want p, we're going to divide both sides by minus 64. Even this side, we're going to divide by minus 64. Okay, if we divide both sides by minus, what happens is that the inequality also is going to change. So here, instead of having less than, you're going to have what? Greater than. And then it says p is going to be greater than. If you type this in your calculator, I think it should be simplified. Let's check that. So you have minus 9 minus, it's 9 over 64. So we have 9 all over 64. And then this is how we solve AMA nature of the roots. We are done with question 1, 28 marks. And then guys, you see, once you get the question 1 correct, you have passed. You have at least at your 50 this thing. If you can get your question 1 in order, you've already passed. So now you can worry about getting a good mark. As we go to question 2, you can worry about getting a good mark. Let's go to our question 2. Guys, another hint here. When they're saying without the use of a calculator, what they're trying to say is this. You shouldn't have your answers as decimals. And then I usually say this, Casio calculator, it allows us to use a calculator without using a calculator. In fact, I think that should be the slogan, Casio calculator, allowing you to use a calculator without using a calculator. When they say you shouldn't use a calculator, what they're trying to say is that we are not allowed to have abacus or something. That's the only thing that they mean. Okay, anyway, let's go and work with exponents and sets. Exponents and sets, we should remind ourselves this, guys. Everything which is not a prime, we're going to change it into a prime. Everything which is in a set, we're going to change it into a fraction form. I think we can write it as an exponential form. This is in a root form, we can write it in an exponential form. Before we go there, let's just remind each other, guys. If I have root 3 all over x squared, this is what we said. We said this thing here is going to be written as x squared, and then root, it's written as a fraction over 3. So this is going to be written as 1 over 3. And then from here, we can raise the power to the first power. This one multiplied by this one is going to give us x to the power of 2 all over 3. We good there. Now, let's get to business then. We're in question 2. On question number 2, we have 20. We have 125. Let's write our question 2 here. So we have 2 points. Guys, I'm concerned that learners seemingly who are not here to learn, like they are not here for the learning. And then they are here. I'm concerned about that one. And then if you are here because you wanted to learn, I hope you are benefiting. That is my hope. So we have 2.1.1. So we have root 125, and then we have x to the power of 6 minus quad root, and then we have 81 x to the power of 8, and then this is going to be all over root x to the power of 4. Okay, let's get down to business now. Inside, we are going to have things which are not prime numbers. We are going to change them to prime numbers. We know how to do that by now. Right? On our calculator, we say 125 equals to shift facts. And then it says this thing is going to be written as 5 to the power of what? Of 3. So it means in other words, we are going to have. Now, guys, here we are going to do these things at the same time. I am going to change this thing here so that it's written in an exponential form. Again, it's written in a root form. We're going to change it and write it in a fraction form. In an exponential form. In an exponential form, it's going to be written as 125. We said this can be written as 5 to the power of 3. At the same time, guys, I'm also changing this. So I have 5 to the power of 3 multiplied by x to the power of 6. This should be all over 1 all over 3. Same as which 1 over 2 we have. Balo, you look surprised. But we're saying we're changing this root. This root, you see this root again? It's a cube root. If you're going to change a cube root, if you have a cube root of something, we're saying this thing here is going to be written as x to the power 1 all over 3. This you changing roots into exponential. It's a rule. That's how we change rules into what? Into exponential. So what we have done here is to change this root here into an exponential. Minus. Here we're also going to do exactly the same thing. So if we change this one, it's going to give us 1 all over 4. Okay? It's running away. So we close the bracket here, we have 1 all over 4. Now, if we change this into a prime product, okay, it gives us 3 to the power of 4, and then we have x to the power of what? Of 8. These two, they are multiplying each other. All over. We're also going to change this one. If they didn't write anything here, what is here? There's a 2. So you have x to the power of 4 to the power of 1 all over 2. Then you're going to raise the power to the furthest power. You multiply this with this one, you multiply this one with this one. I think there's a multiplication in between. Yes. We are allowed to raise a power to the furthest power if there's a multiplication. Now, as we continue with our question, it says, if we say this one multiplied by this one, now, how are we going to type this in your calculator? Just in case you are interested. You will say 3 again multiplied by 1 all over 3. What is 3 multiplied by 1 over 3? It's 1. So I'm going to write this thing as 1 as 5. And if I say this one multiplied by this one, you can do exactly the same thing. You say 6 multiplied by 1/3. 2. And then it says which this is going to be what to it. So it means which you are going to have x squared. Do you get how I get this? Okay, yes. Okay, minus. You do exactly the same thing here. This one multiplied by this one, it gives us 3. And then we say 4 multiplied by 1 over 4. And then we get 3. And then if you say this one multiplied by this one, it gives us x squared. Just in case you are not sure which how did we get this, we are saying 4 multiplied by 1 all over 4. And then it gives us what? 1. So it's 3 to the power of 1. I don't have to write 1 there. And then I do exactly the same thing. Instead of 4 now, I say 8 again. So it's 8 multiplied by 1 over 4. It gives us what? 2. Which means we have what? X squared. All over. If we say this one multiplied by this one, it gives us what? X squared. Say it all. And then from here onwards, these two are like terms, guys. These two are like terms again. Or if you don't mind that, you can say I'm going to take out a common factor. It's not necessary. We have 5x squared, we have 3x squared. 5x squared, 3x squared. What are you going to get? We are going to get what? If we say 5 minus 3, what is 5 minus 3? We get 2x squared all over what? All over x squared. X squared and x squared, they can divide each other out. And then what are you going to be left with? 2. We're going to be left with 2. And then with that being said, it's 3 marks. 3 marks wako is for changing, raising a power to the furthest power, and then you get an answer. Ooh. Now where's it's already 9. So we'll start with our test at 9:30. We'll start with our test at 9:30. Bear with us. So we go to this one. This one we have 2.1.2. So it's 5. It's a minus 2. So it's 5. It's a minus 2. Multiplied by 2. A plus 2. All over. 10a. I'm going to change. 10 is not a prime number. So we're going to change 10. If we change 10 as a prime number, it gives us 2 multiplied by 5 to the power of 1 of a. And then this is minus. We have 2 to the multiplied by 5 to the power of 1 of a minus 1. Multiplied by what? By 2. And then here we can then say we have let's because here we have a minus on the denominator. I think that is the one which is going to be a little bit challenging. Let's start there. So we'll leave the numerator exactly the way it is. We have a minus 2 multiplied by 2 to the power of a all over. Here we are raising a power to the furthest power. We got what? 2a multiplied by 5a minus a minus 2a minus 1 multiplied by 5a minus 1 multiplied by 1 by 2. So let's use the laws of exponents here in this part here. We're going to use the laws of exponents on this 2. If we use laws of exponents on this 2, you will see something here. Check this. Again, it's 2. It's 2. Bases are equal. Again. If bases are equal, what do we do to the exponent? We add them. So here you have 1, and then here you have minus 1. So 1 and minus 1, they're going to give us what? This one and this one, they're going to cancel each other out. I want us, which when we go to the next step, let's just keep that in mind. So we have 5a minus 2 multiplied by 2a plus 2. All over, here we have 2a multiplied by 5a. Then we're going to split now. Here we have minus 2a. We know where 2a comes from. Okay? We said this one and this one using the laws of exponents. And then this one here we split. We have 5a multiplied by 5 to the power minus 1. Now, in our denominator, because there's a minus, we are supposed to factorize. Come and factorize this. If you factorize this, it says what you are going to have. What is common between these two terms here? 2a multiplied by what? By 5a. So if you take out that as common, you are left with what? 1 minus 5 to the power minus 1. And then on our numerator side, we still have 5a minus 2 multiplied by 2a plus 2. Okay, if we subtract this, whatever is inside our fraction here, what are we going to get? Here, guys, we can use the laws of exponents. We are dividing again. If you are dividing powers of the same base, it means this a here is going to go up again. It's positive. When it goes up, it's going to become what? So let's simply put it there and say, okay, this thing here, it goes up, we have minus a here. And then this one here is also positive again. When it goes up, it's going to become what? As you can see here, this a and this a, they're going to divide each other out. This a and this a, they're going to divide each other out, which leaves us with 5 to the power minus 2 multiplied by 2 to the power of 2. Huh? So we have 2 here. All over. Here, we said we can type this in our calculator. Let's put in equal to. Okay, let's go to this one. If we type this in our calculator, what we get? Okay, we can simply write it this way: 1 all over 1 minus 5. It doesn't matter. Since we have Casio calculator, as I said, they said without the use of a calculator. But I said Casio calculator. Use a calculator without using a calculator. So we're going to type this in our calculator. We have 5 to the power minus 2 multiplied by 2 to the power of 2 all over 1 minus 5 to the power minus 1. And then we get our answer as what? As so our final answer is going to be 1 all over 1 all over 5. How do they mark this one then? Let's look. It was 3 marks. Can you see that? So the first mark you're going to get it for changing to prime product. You're going to get 1 mark for factorizing. You're going to get 1 mark for the final answer here. Let me stop here so that we can